we'll get started. So we can see your interesting, very exciting session. So 안녕하세요. 반갑습니다. 2020년 스마트 비즈니스 엑스포에 참여해주신 여러분께 감사드립니다. 발표를 시작하기 전에 몇 가지 안내 말씀드리겠습니다. 저는 이번 세션 사회자로 카이타에서 회장 직책을 맡고 있는 브라이언 선 혹은 손지민입니다. 원활한 진행을 위해서 참가자 전원 음소거를 합니다. 발표 중에 질문이 있으신 분들은 채팅창이나 Q&A 창을 통해서 한글 또는 영어로 사회자에게 질문해 주시면 발표 질문 시간에 종합해서 사회자가 발표자에게 대표로 질문하고 답하는 방식으로 진행합니다. 발표 내용은 전부 레코딩하고 이벤트 후에 공유될 예정입니다. 발표 중 여러분의 모습도 같이 레코딩될 수 있고 공유될 수 있다는 말씀 드립니다. 발표되는 내용과 슬라이드는 달라스 한인상공회의소와 한인 IT연합회의 서면 동의 없이는 재사용하거나 공유하실 수 없습니다. 오늘 발표 내용이 필요하시거나 다른 분들과 공유하시기를 원하시는 분들은 달라스 한인상공회의소나 한인 IT연합에 연락해 주시길 바랍니다. 오늘 발표는 Build a Serverless Hybrid 제목이 뭐였죠?
Build Serverless Hybrid Cloud using Supersonic Java.
Yeah. Build a hybrid cloud using Serverless Supersonic Java라는 내용으로 데니오님께 발표해 주시겠습니다. 발표는 영어로 진행됩니다. Welcome everyone. Thanks for joining us today at 2020 Smart Business Expo. Before we start, I'd like to tell you a few housekeeping items. The moderator for this session is Brian Sun, who is the president at Kaita. All participants will be muted throughout the session. Any question you may have, please use the chat or Q&A window, the moderator, either in English or Korean. The moderator will collect all questions and ask the speaker later if in Q&A if time permits. The session will be recorded and shared later. During the session, some of it may be included and shared as a part of the entire recording. All content in slide cannot be used or shared without GDKACC and Kaita. If you need any content and or slide, please contact GDKACC and Kaita. Today's presentation is Build a Serverless Hybrid. Yeah, you can say that.
Yeah, I will do that. Yeah, Build a Serverless Hybrid Cloud using Supersonic Java.
There you go. By Daniel O in English. Speaker, now you can present.
Thanks, Brian, and hello, everybody, and thanks for joining again this breakout session. As Brian mentioned, this is the second breakout session and a repeated session. Okay, let me share my screen first. The one desktop. All right, and I changed my screen to presentation. Okay, hopefully everybody see my screen now. Okay, thanks for joining the Build Serverless Hybrid Cloud using Supersonic Java. Yeah, there are a lot of buzzwords in the title, and then some people know what serverless is, some people don't know what hybrid cloud is. I'm going to talk a little bit about that thing during the demo and then break out my slides there. So my name's Daniel O. I'm working for Red Hat, just like Brian, and then I'm principal technical marketing major to specialize the cloud-native application development. I'm trying to evangelize a lot of enterprise developer, but also IT operation team, how to build up their DevOps platform or hybrid cloud platform with the agile DevOps practice, but also lots of related technology and open source project. I'm also CNCF ambassador. So if you have any question around the Cloud Native Computing Foundation project, the Kubernetes and Prometheus, but also there are tons of projects under underneath the CNCF, just let me know. And yeah, here's my contact point, Twitter, YouTube channel, and my Git repo. So maybe easiest way, you can subscribe my YouTube channel, and then there are lots of practical technical demo and tutorial and technical tips. You can follow that maybe 5 minutes, 10 minutes. All right, let's jump into my session. Okay, so let's try to just one step back and to understand why we needed to think about Java to build your own hybrid serverless. Because people maybe think of Java is not good. I mean, heavyweight is a pretty old technology. So that's why a lot of the student, even college student, university student, even high school students, are more interesting about Go program language or Python for AI ML or JavaScript, Node.js, more rich front-end application development like a mobile application, etc. But the truth is there are more than 7 to 10 million Java developers around the world. They still develop business application every single day for serving some business application, but also the customer facing end user application like Airbnb or Twitter and etc. So 25 years ago, the Java was born into the world, and then after a few years later, so this is the main uh, cost how to build up your business application on top of Java technology. So there are two parts to expand your cost, like capex and opex. So first year you need to almost $463,000 to purchase hardware, software, and network device, and a web server, application server, and database, etc. And then after that, you have to more than $80,000 for each year to maintain your business application. So that's why the startup company was not easy to uh, build up your Java application for their production environment. It's kind of huge money at the startup time. In an architecture perspective of a Java application, we have one single architecture, like a monolith application. People depict that monolith application is a big elephant, like a King Kong giant and Frankenstein, the application. But it was really awesome at a time because it's 100% capability already in there, and then you can deploy that monolith application, just a few app server on top of the bare metal or virtual machine, and totally we're working on internet technology. So pretty awesome. But there are some huge constraints to maintain that application along with the new technology such as Kubernetes and Docker container and the microservice application architecture. So this is the new technology came up in the last 15 or 20 years after Java unleashed upon the world. So mainly 2006 and the Amazon first time to serve the Amazon instance like an EC2 instance, and then the startup company or small company didn't worry about any longer to purchase the big hardware or software. They just pay the instance consumption just like a pay-as-you-go cost strategy, and then just small money enable the company to start up their business at a time. You know, Java 6 is a huge change improvement, and back in 2009, and the Docker container is a kicked off the new container technology, not serverless container on Java world, but it's more packaging technology. So once you create your application, you could deploy any environment, your Java application. But problem is you have to figure out actual deployment environment. Okay, I need to deploy this application to testing environment or production environment. And then each environment has different configuration. For example, the database IP address or backend legacy system address, etc. So you need to figure out that problem using multiple configuration file or metadata database or some static file, etc. So Docker container make that change that issue. So with the Docker container, containerize your application, but also the packaging includes dependency, which means you just create the one image file, and then you can run any environment from local machine to production environment, even Amazon Lambda. So Kubernetes is a totally changed the world, like a game changer. It's a new infrastructure, runtime environment, running on container as orchestration. So this is a huge change, change in technology impact the current application architecture and the blueprint as well. So after that, so people don't want to purchase the hardware, software, etc. So they really want to use the public cloud resources like Amazon, Google, Microsoft, and there are lots of company provide the cheaper prices of the instance like a storage and disk and compute, etc. So the point is, you just need to pay the how much you use the resources like a memory, CPU, and disk and network traffic, etc. So in this circumstances, what is the most important thing for your cost perspective? First thing is, if you want to reduce your cost to use your public cloud, you need to make it smaller and make it faster. So for example, I have one application, I can package this application 1 gig, or I can package the same application with 100 megabyte. Which one would be better to run the public cloud? And also bigger size and maybe bigger traffic, and then small size and fast startup time. So it's already about your cost. And then with the Microsoft's application architecture came up, and after that, so Java is changed a little bit, and actually changed a lot. For example, the Microsoft's application architecture allows us to create this single application can be deployable any environment in a small memory footprint and just startup time, just a few seconds. So Spring Boot is open Java framework to do that. So with the Spring Boot application, you just need to start up maybe 5 seconds to start up your application, but also you can deploy the single business functionality with the packaging that application and deploy Kubernetes cluster. But in the middle of this diagram, the Java still has dynamic behavior. So I'm going to talk a little bit about what dynamic behavior in Java technology. So let's try to think about and understand how Java was developed and designed back in 1995. So Java designed for a high network throughput, and then also Java designed to be long learning process. So once your application start on your production environment, and people only care about application should be running all the time, 24/7. If their application is shutting down, it's totally disaster. And then you need to figure out where is the problem and then how long do I need to fix that problem. So long learning process and then, long learning process, but the startup time maybe is too long, maybe 5 minutes, 10 minutes, sometimes 15 minutes to start up, but nobody care about this problem because so most time the new release task will happen during the holiday or even late night or early morning. So end user prospects, they don't even know where the application was done and restarted. So this is the normal application development life cycle, but also the architecture, Java architecture to serve the business functionality. And also Java is the provide rich dynamic behavior running a mutable system like a virtual machine and bare metal. And then once you package in your Java application, you can have intermediate code, also known as bytecode, and that bytecode not actual complete code. When you run that bytecode and the JVM try to multiple tasks to run that application as a thread or part on your app server. But In the meantime, the infrastructure already moved forward to immutable infrastructure such as Kubernetes or Red Hat OpenShift container platform or container-based public cloud server, etc. So what this immutable infrastructure like a Kubernetes impact the Java technology, but also all the other application framework. So you have one application which have one business capability, such as the subscription or searching your shopping cart or reservation, your hotel room, etc. But that application can be scaled at speed on Kubernetes cluster. So, but in this diagram, as you can see, we have the same container platform like a Kubernetes and the same worker node. You can run your application with the same resource density. But as you can see, the Java running on a hotspot, you can only deploy 4 applications as a pod. But Node.js 8 and the Go is 12, 16 actually. So this is the reason why a lot of people, a lot of the awesome Java developer really want to use Node.js, the Python as the serverless application. So serverless application just came out just 1 year ago as a popular thing because enterprise, a lot of enterprise company looking forward to the best way how to reduce their cost to maintain their application, specifically running on top of the public cloud. Maybe the one good solution is to use serverless architecture, because when their company they keep monitoring their application utilization. So some of the application, maybe 30% of the application can be scaled down to 0 or idle or hibernate, and which means not every single application doesn't need to run all the time. For example, you can go to eBay or Amazon.com to shop new TV or a mobile phone, but most people just go to some shopping list, but very sometimes maybe 1 of 10 the visiting, you just go to purchase that item. So this is the how to use the application and end user's perspective. So that's why the fast response time and the fast startup time and a small memory footprint. This is the really interesting to run your application on Amazon Lambda, such as the serverless platform. So Java is a very low percentage to use this technology because Java still looks like a heavyweight and the slow response time. And also, even though you select Java as a serverless application on your production environment or your startup company, and then now you gotta figure out which is serverless technology would be fitting into your environment. So as a tool, as a framework, as a platform, maybe you wanted to manage your platform, or you just pay the money and use the manageable platform like Amazon Lambda or Google function, etc. So too many choice sometimes not good for your the business. So, and in the meantime, actually, Java keep trying to evolving their own technology to catch up the container technology, Kubernetes technology, and serverless technology, and event-driven technology. So they make to optimize their application artifact and the runtime environment along with the Linux container technology, and change the garbage collector, make it smaller. There are variety of the Java compiler along with the different environment like Android and just Linux operating system and the Windows system. But still, that's not good enough. So that's why people keep looking for, we need something different to fit in the new technology. So I'm gonna really happy for interesting Quarkus is open source project, and then Quarkus enables Java developer to develop the cloud-enabled microservices, but also you can design the serverless application on top of the Kubernetes cluster. So this is not some migration toolkit. This is a more developing brand new application on top of a Linux container technology, but also Kubernetes platform. And then you can change this application any environment, from local environment or the hybrid cloud and the serverless platform on public cloud, etc. So Quarkus changed the centerpiece of this diagram, the root cause of the make the Java slower and heavyweight. As you can see, it's a small memory footprint. So as I already mentioned earlier, so this is the way the traditional Java stack is working on that. So as you can see, there are two steps: build time, runtime. At the build time, you can just build and packaging your Java application using Maven or Gradle toolkit, and then you have a bytecode after packaging. And then when you run the application running on your application server or using just Java command line for standalone application, but behind the scene, Java tried to load the configuration file and parsing them, and then loading classes file and enable features, some dependency library, but also try to annotation scanning and parsing descriptor. And there are multiple steps in this slide. The Java tried to do from step 1 to step 5. And the step 6 is an actual Java application running, what we needed to actually. So Quarkus just shipped all the required tasks from right to left. And then when you run the Quarkus application as a Java, and then it's exactly stop the application without any prerequisite thing. And also, you could have two options to packaging your Java application and run two different type of the vulnerable file. So one is you can actually run JVM and running on top of the hotspot technology and using the JVM, but also you can packaging the application as an executable file like a Go, Python, and then running on top of the subtree VM, not JVM, is to optimize the runnable runtime. And one more thing, Quarkus provide the funky features, which is provide standard Java portable API for Java developer to create and write a function and then deploy that function into a variety of the serverless platform, such as Amazon Lambda or Microsoft Azure Function and the Google Cloud Platform with the function technology. And also you can deploy that function into your on-prem Kubernetes cluster with the knative capability. So in the end, for developer standpoint, I can develop Java application. I can develop Java application as the traditional Java application, long running process. But also you can evolve the traditional application to function anytime and then deploy anywhere without code change. This is a huge impact for Java developer to handle the serverless technology. So a lot of Java developer out there, I already said more than 7 to 10 million Java developer around the world, they have to run some new technology or Go or Node.js to develop serverless application for their business, but they don't need to do that any longer because they already good skill of Java technology, and they just to use the Quarkus without any steep learning curve. This is a huge benefit for the developer. All right, I'm going to stop talking here, and I'm going to change it to live coding and my demo. Let's get into my demo. All right, here is my local environment and my IDE tool, VS Code. And there are multiple ways get starting the Quarkus application development from, you can use code.quarkus.io, the website, the project generator. If you have some experience with this Spring Boot stuff, It's almost same screen initializer. And also you can install or add extension around the Quarkus tool on your IDE tool, like a VS Code or IntelliJ and NetBeans or Eclipse, or whatever you need. And then that tool gives some welcome page to create a Quarkus project and give some more default functionality how to implement Quarkus application. So I'm going to use that the Quarkus today, and then I'm going to use Maven, and then you can define your project group ID and artifact ID, and also project version 1.0 or 2.0 or maybe 0.1, and the package name like a me Daniel, and then so one resource name will be the resource name, which means a Java class, which export the RESTful API by default. The Quarkus provide that feature. So let's try to set it up, greater resources here. And extension is all Quarkus capability, but I'm not going to add any extension at this moment. And I'm going to save my file project, my temp directory, and now we can see here project is automatically generated. When you go to PalmXML, this is the structure of a Maven project to packaging your application. And then that, when you package your application, there are necessary and dependency, like a capability, like a REST easy, make your application to export the RESTful API. And then the ARC is enable you have a CDI, the dependency injection capability, and a unit test. And this is another the REST to secure, etc. All right, this is one more thing. This is the 191 is a final, it's a raised Quarkus version. So when you generate the Quarkus project, it's automatically generate the raised using raised version of Quarkus. Let's go to Java file here. As you can see, pass annotation, export the endpoint. In this case, the REST eg-hello is the endpoint. And then when you call this endpoint, we got the return hello, just like a hello world application. So what is the first step as a Java developer to develop a Java application on Quarkus framework? Just start the application runtime. So I'm going to open my terminal window, and I'm going to using the Maven command line. And then here's the Quarkus :dev. It's one of the feature of Quarkus framework to start up your Quarkus application as a live coding and actually development mode. As you can see, live coding activated. So when you activate this application, I'm going to split my terminal window, and I go try to access endpoint 8080. And REST easy and hello. As you can see, we have a right return value here. So when you change the code, let's say, okay, I'm going to change my code to develop function or the different business requirement, like a welcome virtual smart business expo. I just save a file, and then let's try to access the endpoint one more time. As you can see in the behind the scene, Quarkus automatically recompile, build, packaging, deploy your own running on top of the running environment. And then we got also new return result here. So you don't need to even recompile and repackaging and redeploy this application, but also you don't need to restart your running Java application. Just a simple application, but just imagine you need to keep changing your code every single day from your home and from your company, but it's totally save your time. In the end, it increases developer productivity as well. And then, so we're gonna change this application to function. This is the traditional Microsoft application to export the RESTful API, but this is not the function. So we're gonna change this application as a function. In order to that, I'm gonna use the one of Quarkus extension such as capability, as already mentioned earlier, as funky. So let's try to add a new extension here. It's the funky here, funky binding. And once you add the funky annotation, the dependency automatically inject to your PalmXML, but also download all necessary jar file on your local environment. And you don't need to pass endpoint any longer, and then you don't need to get method any longer here. Just using just func annotation here. Let's try to take a look at that PalmXML. Yeah, Quarkus funky HTTP binding here. And then let's try to add the new func annotation here, func annotation. And then if you're using func annotation, the function name is the same as the method name. So in this case, your function name is hello, and you can also define your own function name with the argument when you use the func annotation. I'm going to do that just a little bit later, and then I don't need to do this unnecessary packaging here. So now we can see here, so we have a very short and simple application here. So even when you change this application to function, but you have a fantastic and more small, the less line of your code. Try to access this application as a function. And now we gotta go to hello. And now we have the same result here, the welcome virtual smart business expo. So this is a very easy and simple way to change your existing microservice application to serverless function. And let's try to add some another function here, but we're going to add the dependency injection, actually context dependency injection, one of the main major capability of your microservice application. So in order to do that, we're gonna create a new directory here, and then new Java class here, like a service, reader service Java file. And let's say define this application scope, and then one Java method like a greeter, and we need to one name parameter because I'm going to pass down this name here, welcome, and we're going to add the parameter, and for hybrid serverless development with Quarkus. Okay, I just create a new service here to use the dependency injection. Let's go back to our resource file and define that CDI bin, and then create a new function here one more time using function. But at this moment, we're going to define the actual function name hybrid rather than using method name. Greeter, and we need to define the parameter here. And service greeter name. Okay, I got this, and then no more error, and then just to make sure there's no error. And then let's try to add this application using parameter, pass down then my name, and then not hello, it's a hybrid. And now we got to return hello Daniel O for hybrid serverless development with the Quarkus. Pretty awesome, pretty easy. And we in this case we just use the we just create a new function, but also we can use the CDI bean just like a traditional Microsoft application capability. So next step, I'm going to deploy this application to Amazon Lambda because we already create the function. Pretty easy, pretty fast. And you know, to deploy this application to Amazon Lambda, if you have some experience to deploy Java or the other language application to Amazon Lambda, you need to figure out the Amazon Lambda command line to deploy that thing. Or sometimes you're going to use the go to Amazon web UI and web console and upload the file and packaging that thing, something like that. But I don't want to back and forth to do that. So first thing is we're gonna add a new extension here, funky annotation for Amazon Lambda binding. It extension automatically bind your Java application, make it deployable in Amazon Lambda. And try to packaging this application. But for that, I'm gonna one more thing. Just go to Amazon Lambda, and I'm gonna comment. And let me try to one more thing. Maybe packaging this application. I'm gonna skip the unit test. So when you're packaging your application, you can have a thin jar, like a jar file to run on your application. So as you can see, we can use Java command line to run this application, standalone application, and runnable. And then, but for that, this is my resource monitor on my my local machine, and this is the memory tab. And when you go to the find the searching JVM, and there are a lot of JVM, and here's a 220 and a 77. And I go back to my ID command, and then I just run my application. Oh, the same port using. So actually, I had a same mistake during the first my session. Okay, just try to one more time, and now we can run this application. And let's try to one more time to make it see easier. Okay, so application just running, and now we have here 0.9 second to start off this application, and also go to the application, and then we got a same name, or maybe we change the name, like a Bryant name, and then we got some Bryant name is here. Okay, and then go to the resource monitor, and now we have another one. It's a 123.9 megabyte as a memory footprint. Just make sure to remember this number. So 120, something like that. And go back to here, and I'm going to start my application. And then I'm going to try to package this application at a native compilation one more time. So maybe in compilation, clean packaging. I'm going to skip unit test and native compilation. So the reason why I skipped the unit test here, because Quarkus automatically generate your test scenario here. And then when you generate the Java class, the return result is hello. But during the application change, we change the return is the welcome virtual smart business expo. So in order to pass the test scenario, we need to change this return, but also the endpoint as well. But I don't want to do that during the demo time, just save my demo time. That's why I skip the test scenario during Maven packaging. So native compilation, there are a few steps to make it happen. First thing, so the Quarkus build this application as a thin jar, like a jar file, and then create to executable file as a binary based on GraalVM or the Manuel based image, just like a containerization, like a Docker container. Once you create this application as a binary file, and you can run any environment without JVM, and then as I already showed that we shipped to left side at runtime, at build time rather than runtime. So this is how it works. So it takes a little bit longer than the general application packaging. So it takes 1 minute 24 seconds, but it totally depends on what kind of application you are developing or complexity, etc. And then we can run this application target directory, and we don't need to use the Java command line because we don't need to use JVM any longer. And run the application, as you can see, is instantly run your application. Let's try to one more time to run. And then here we just to, okay, maybe this one, okay. For 17 milliseconds to start up this application, so previously it took 0.9 seconds, and now we have 17 milliseconds, so maybe 30 times, almost the 80 times faster than startup time, but still same application. Because when you go to when you try to access the endpoint, and then we got the same widget, hello, Brian, son for hybrid serverless development with Quarkus. So same widget, same functionality, but the small, fast, maybe 100 times faster memory, the 30 times faster the startup time. And also when you go to resource management here, and then try to find out, and then you can find here 7.8 megabyte as a memory footprint. Previously, we needed 123 megabyte. It's almost 30, 80 times the rest of the memory footprint. So as I already mentioned earlier, for developing serverless application or functional application from on-prem or to public cloud like Amazon Lambda, now the Quarkus enable you to still develop Java application and deploy this application into that infrastructure. Then go back to my ID load, and then I'm gonna to stop my runtime environment and go back to Palm XML, and then I'm gonna the on command the dependency here. So what I'm gonna do next thing is I'm gonna packaging this application one more time, but not native file, and I'm gonna skip unit test one more time. So based on this Amazon Lambda funky extension, generate all necessary Amazon stuff. So when you go to target directory, you can see some kind of magic bash script automatically generated, which includes all the Amazon Lambda CLI. So very complicated, a lot of parameter, but you don't need to worry about any longer. The Quarkus automatically generate this bash script. You just need to do is run this bash script. Also, there are provide 2 YAML file to test locally before you deploy this application function to Amazon Lambda. So here is the Amazon Lambda, my credential here. As you can see, let me try to log in. The session is expired. Okay, here we go. And when you go to function, there's a non-function deployment at this moment, and I'm going to try to deploy this application. But so you just need to run this manage bash script here. And then the one parameter is the Amazon Lambda resource name, the resource key. It specify which resource you want to deploy your function. So this is belong to my credential. So let's try to deploy this application. It takes a couple of seconds, but sometimes 30 seconds to deploy this function. It depends on the complexity or size of your application. Okay, we just successful return, and then go back to Amazon Lambda and reload this application. Now we have a serverless demo, and then try to test with the configure new greeter. Oh, actually, I'm sorry, I missed one thing, because you need to define which function should be deployed in Amazon Lambda. So we have actually two functions. So we need to specify which function should be deployed in Amazon Lambda. So maybe want to do hybrid. And for that, we just need to delete. Once you finish your function testing or deployment, you can just run same bash script but with the delete parameter, and then your function automatically delete. It's simple and easy. And then we're gonna need to package this application one more time. And then the all generated file is deleted and regenerated, and then try to create one more time this application, deploy hybrid. And it takes another few seconds to deploy our function to remote Amazon Lambda. Sometimes it's a little bit slower, depends on the network bandwidth. So just reload the application and then create a new test event greeter, and then the parameter name, my preferred name, then and create, and try to fire up to test this function. And then you gotta have welcome, then for hybrid serverless development with the partners. So in the meantime, I didn't even change my application. So I just want to delete one and go back to here, and the function is gone. And then one of our function name is a method name hello, and then we just save that file, and then just Maven packaging and just create a new function. Pretty easy. But in the meantime, I didn't even try to change my application along with the Amazon Lambda interface. And create a new one, and create. And this will be this will deploy new function. I mean the hello function to Amazon Lambda. Previously we deployed greeter function to Amazon Lambda in a success. And then let's try to reload this application, and then hello demo, and then create a new test event like a hello. And though there is no parameter, so just empty, and create that thing, and fire up the test event. And then we have the return here. So welcome virtual smart business export. Just like we got this result in our local machine, pretty easy. And then we don't need to that function any longer. Just delete that thing. So which means you don't need to pay for that any longer to Amazon. And then go to function, and you got this one. Okay, so we just deploy. We learned about how to develop Microsoft's application with some CDI and the context and dependency injection and traditional RESTful API. But also we just learned how to evolve this traditional application to function, and then how to deploy that function, the most popular serverless platform, Amazon Lambda. And now we're going to deploy this application into on-prem Kubernetes cluster, because Kubernetes is already provide serverless feature based on Knative project. So in order to do that, we needed to existing Lambda extension, because Lambda and OpenShift and Kubernetes extension is exclusive, and try to add a new extension like OpenShift. So this extension enables you to create all the Kubernetes YAML file. So for example, let's try to Maven package once again. And then you can have actually, when you go to target directory, and now you have a Kubernetes directory, and then you can go to YAML or JSON file. So it's a Kubernetes YAML or OpenShift YAML. So when you click on the Kubernetes YAML file, and then you can find all required Kubernetes resource, like a service or a deployment, and an OpenShift case. You got a more the service account, deployment compute, and image stream. This is all require the resources to deploy your application to OpenShift or Kubernetes platform. And we need to actually package this application as a Linux container. But I already did just 30 minutes ago, just save my demo time. And then here is my OpenShift cluster. This is a ready version. We just released OpenShift 4.6 based on Kubernetes 1.19 the last week. So when you go to developer console, and you can actually deploy container image from inside OpenShift or from outside external container registry, like a Docker Hub or Kubernetes.io. So I'm going to use my one of the container image already pushed it just 30 minutes ago. And then one thing you need to do to select is a Knative service. When you click on deployment or deployment configure, this application will be deployed as a traditional application, not serverless application. So, but when you click on Knative serving, that application will be deployed as a serverless function. Let's try to click on, and I already packaged the application as the native binary file. Because when you click on view logs file, how to run this application, and you can see the application pull down first and then just run. And then we just need to 90 milliseconds to start up, almost same when you run this application on my local machine. And you go to topology view, and then you can click on the endpoint, and you can see the welcome page of the application. So let's try to access the endpoint as we test, I'm going to use Brian's name. Okay, and try to the actual endpoint here, and delete the protocol and the endpoint hybrid. And now welcome Brian to Serverless and work. Let's try to one more time. Maybe some people assume this is the maybe kind of caching, but this is not. I'm gonna need to capital. And now we have welcome Daniel or hybrid serverless development with the Quarkus. And then this application will be scaled down to 0 if there have no demand or request this application. That is the main behavior of a serverless application. So serverless application can be running anytime, but if you don't any request to that application using RESTful API or the web browser access, and that application should be down to 0, like a hibernate. And then when new request is incoming to the data application, your serverless function should be scaled up automatically. But the problem is how long does it take to run your application right after you got an incoming request? Some applications should be maybe 5 seconds. Some applications should be needed to take maybe 1 minute or just 15 seconds. So, but Quarkus just need 1 second to start up if you use a native compilation binary file. So in the meantime, the application is terminating because default configuration to scale down to 0 on Kubernetes Knative serving is 30 seconds. So we need to give some more, a few seconds to scale down to 0 completely. And it will be maybe the next 5 seconds to scale down to 0. And then, yeah, just scale down to 0. And then we just to run one more time this application and go back to the web console, automatically scale up when you call this endpoint, and they're just already up, and then go back to the same result. So this is the reason why the fast response time, but also fast startup time is a really important thing when you design and develop your serverless application. And this is the reason why people really love to use Node.js and Python rather than Java to run your serverless application on top of Amazon Lambda. But with the Quarkus, it's totally blow your mind, and you could still using the Java technology. Okay, I'm gonna end my demo, and I got a couple more slides here to wrap it up. And luckily, I don't see any specific question in the Q&A box at this moment. And then, so if you're more interested about Quarkus application development, but you don't know how to get started, and here is a good resource here. So you can go to bit.ly URL/try-Quarkus, and then it's 100% free interactive training course. Go to this URL based on web browser, and when you access this, there are tons of the Quarkus training scenarios, and you can learn about that. One scenario takes 10 to 15 minutes, and from fundamental to advanced stuff. And the code.quarkus.io is a project generator. I already mentioned it earlier. You can go there and just select whatever you need for dependency, and click on generate your project. Automatically download zip file and unzip file, and open up your ID tool, and just get started. And here is the IDC report compared to performance standpoint, Quarkus versus traditional Java application. And also, I already mentioned that my YouTube channel, the bit.ly/Daniel TV, I already posted a lot of the Quarkus technical demo. And if you have some question, how to get started Quarkus application development, and I strongly recommend go to the channel and subscribe that, and then find the technical demo. And if you have some issue when you try to do same thing with that demo video, and just comment on that or let me know that, I will help you out. Okay, I think it's done. Any question if you have, and please don't hesitate to put in the Q&A box.
Yep. So we're going to thanks Daniel so much for the awesome presentation. We'll take a question. So otherwise I have some prepared question. 질문 받습니다. 질문 있으신 분은 Q&A Q&A 박스에 넣어주시기 바랍니다. You can type your question in Q&A. Otherwise, there are the question I can ask. Let's see. Okay. Actually, we'll wait for the question. So meanwhile, we'll proceed with some sample question. Okay. So
Sure.
my question is that Spring Framework is the most popular Java framework as of now, right? So how is Quarkus different from Spring Framework or Spring Boot, and what other language does it have? In Korean, Spring Framework가 현재 가장 많이 쓰는 Java framework인데, Quarkus가 Spring 비해서 어떻게 비교되나요?
Yeah, yeah, that's true. Spring is already opinate Java framework, and then it was born back in 2013. It's more than almost 7 to 8 years. And Quarkus is just a baby project, and then Quarkus really bit more fitting in container technology and Kubernetes technology. So Spring Boot was born both for Linux container and Kubernetes. So there are some constraint or restriction to optimize the Spring Boot application running on top of the Linux container and Kubernetes. So for example, if you run Spring Boot, same Spring Boot application with the same functionality like a RESTful API, like Hello World, and then you have maybe 100 megabyte. But Quarkus is just the 10 or 7 megabyte. And the startup time, and the Spring Boot is a 1 or 2 second, and Quarkus 0.5 second, or with the neighbor comparison is a 13 millisecond. And the memory footprint is a huge difference between the Spring versus Quarkus. But also Spring provide lots of Spring ecosystem, like a Spring Cloud, etc. So it totally depends on what kind of business application you want to develop and deploy on Kubernetes cluster. So for example, if you have only 10 Microsoft application and deploy Kubernetes, and with the Spring Boot, go for it. And then, yeah, there's no issue. But if you have some issue, resource management, and then the cost to problem, because you have 100,000 application running on top of the Kubernetes as a pod with the fast scalability and this speed response time. And the Quarkus is a totally alternative way to fix that problem. And also serverless application, event-driven application, the Quarkus gives a more fast response time and startup time to fit into that technology.
Thank you. I guess we'll take more question, and please type your question in the Q&A box. But I'll ask the next question. How many companies are looking to hire Quarkus developers? Is there going to be an opportunity to get hired if I learn Quarkus? In Korean, Quarkus를 배우게 된다면 쿼커스 쓰는 개발자를 고용하는 회사가 많이 있나요? 기회가 많나요?
Good question. I'm not sure actually. It's as you see, Quarkus, the Red Hat released Quarkus just 6 months ago, and actually the community project we got started back in 2017, and then we just spent almost 2.5 years to launch this project, and then we got a lot of good successful story from customer side of even before we released this project officially. So the Europe and North America, a lot of telco companies and the public sector companies, they already adopted Quarkus project and build or migrate from Spring Boot to Quarkus in the production environment. So I think it could be better. And I would say if you're looking for an alternative program language for your next IT career, rather than Java, but still you got a chance to improve your Java skill to have a great job in IT industry. If you willing to learn Quarkus stuff, because Quarkus is standard Java skill. You don't need to worry about some new shiny thing. It's a standard Java, but more convenient tool, make it your life happier.
Thank you for the. I guess we don't have any questions. So, but I'll ask you one question. Otherwise, we can close it. I guess one additional question. So, does Quarkus support other JVM, Java Virtual Machine-based compilation language such as Scala or Groovy? Quarkus는 다른 JVM, Java Virtual Machine 되어 있는 스칼라나 Groovy도 지원을 하나요?
네. We support Kotlin as the extension for now, and the Kotlin and just OpenJDK. That's all. But if we have a more PR or request from customer or even lots of developer, why not? That's the beauty of the open source project.
Cool. I guess no question other than that. So we'll close it. 오늘 참여해주신 여러분들과 발표해주신 제니오님께 감사드립니다. 앞에서 말씀드린 대로 이 세션은 리코딩되어서 다양한 방법으로 나눌 예정입니다. 오늘 세션을 다시 보고 싶으시거나 못 보신 세션이 있으시면 레코딩 세션으로 확인해 보실 수 있습니다. 오늘 멋진 2020년 스마트 비즈니스 엑스포를 준비해주신 달라스 한인상공회의소와 세미나에 도움을 주신 카이타 여러분들께 감사드리며 달라스 한인상공회의소와 카이텍에 관해서 더 알고 싶고 궁금하시면 달라스 한인상공회 웹사이트와 여기 나와 있는 웹사이트와 카카오톡, 페이스북, 링크드인을 통해서 다양한 활동을 하는 카이타 SNS 채널 혹은 여기 contact@kaita.org 이메일로 보내주시면 감사하겠습니다. 또한 kaita.org로 등록하시면 카이타의 업데이트를 뉴스레터로 받으실 수 있습니다. 다른 세션에도 많은 참여 부탁드립니다. 여러분 감사합니다. Thank you for all to attend this session, and thank you Daniel for presenting the session. Today's session has been recorded and will be shared via various ways. If you want to watch today's session again or sessions you missed, please check for recorded sessions later. Special thanks to Greater Dallas Korean American Chamber of Commerce and Kaita staff to prepare this wonderful 2020 Smart Business Expo in these hard times. Please visit koreanchamber.org as shown here for more information about GDKACC, and please join Kaita through KakaoTalk, Facebook, and various SNS channels. Or contact us at contact@kaita.org if you have any question. Thank you all again for your participation, and please join us other session as well. Thank you so much. Yeah, that's the end.
Thanks all. Have a good rest of the day.
Thank you.
Bye. Cheers.
Bye bye.